Hello and welcome, Cannon County Algebra 2. Today we are going to talk about three trigonometric ratios that you, again, just like yesterday, this is probably review for you if you had geometry class last year, and it's not going to be review for you if you did not have geometry class. Either way, it's going to be important that you understand sine, cosine, and tangent for what we're going to be doing next. So here we go. Mr. Lyon, I have to ask you to keep an eye on things from over there. Let's talk about sine, cosine, and tangent. Before we get to that, you need to understand a few words some vocabulary that have to do with sine, cosine, and tangent and how they relate to right triangles, okay? And this is what I'm talking about. We've got a triangle here and an angle. This angle is theta, and we've got three words here. You got the hypotenuse. You already know what that means. That's the angle, or that's the side opposite the right angle. But then we've got opposite and adjacent. Opposite is kind of obvious because it's the side that's opposite the angle we're talking about. In this case, it's theta. The adjacent side, adjacent means right next to. There are really two sides right next to theta, but one of them already has a name. It's the hypotenuse. So the other one is the adjacent side. So whenever I draw on a triangle, there's going to be, with an angle, there's going to be an opposite side, an adjacent side, and a hypotenuse. Okay, let's look at the same triangle, but let's put theta in a different place. What if theta was up here? Well, now this is the opposite side. This is the adjacent side. The hypotenuse is still a hypotenuse because it is across from the right angle, okay? All right, what does that mean? Well, we're going to talk about three trigonometric ratios, sine, cosine, and tangent. All they are is fractions. They're just ratios. They're ratios of sides of a right triangle. So sine, which is abbreviated SIN, but it's pronounced sine, sine of theta is equal to the opposite side divided by the hypotenuse. And again, I know this is review for those of you who took geometry last year, but a lot of you didn't. Cosine of theta is adjacent divided by hypotenuse, and tangent of theta is the opposite divided by adjacent. Some of you may remember in the past that you used this to help you remember SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, SOHCAHTOA. That's just an easy way for you to remember these three formulas so that you don't have to write them down, okay? So you've got the sine function, the cosine function, and the tangent function. What we're gonna do today, eventually we're gonna graph these functions, but for today, I just want you to be able to find the sine, cosine, and tangent when you're given a triangle with the sides. So I'm gonna do that by putting the computer on here. Let's see how that shows up well. I'm going to zoom in just a little bit more. Okay. And this one says, find the sine of angle E. So all you have to do is take a look at angle E, which is right here, and you know that the opposite is 15 and the hypotenuse is 17. So that's it. If I go here, let's see if I can do this. There we go. 15 over 17. And that's the answer. That's it. This one says find the tangent of angle X. Here's angle X. You know that tangent is the opposite divided by the adjacent. So that's opposite 77 divided by adjacent 36. Opposite is 77 divided by adjacent 36. Now, one thing you want to be careful of is it says to write your answer as a proper fraction, an improper fraction, or a whole number. You might want to check to see if 77 over 36 reduces. So if you want, you can take out your calculator and type in 77 over 36 and see if it reduces. It does not. So 77 over 36 is going to be our answer. Okay? I am going to skip a level here and see if they can make these problems any more difficult for us. Find the sine of angle W. Well, let's try that one. What's the sine of angle W? It's going to be 60, because that's the opposite, divided by 68. 60 divided by 68. Well, that does reduce, doesn't it? So if you want to use your calculator to reduce that, certainly you can probably do that one on paper pretty easily. But 60 divided by 68 reduces to 15/17. So if you're going to do the IXL, or if this was a test, you would want to type in 15/17, because that would give you, you don't want to type in something that's not reduced, that's all. Correct. All right. Find the cosine of angle U. The cosine of angle U. Well, this one looks a little more difficult. Why? Cosine is adjacent. Remember, this is the hypotenuse over here. It's adjacent, which is 5, divided by hypotenuse. Well, we don't know what the hypotenuse is, so what should we do? Well, we're going to have to solve for it using the Pythagorean theorem. So let me move this out of the way. We've got 12. I'm just going to draw this real quick. We had a 12 and a 5, and we were trying to find that hypotenuse. Well, we know that c squared is equal to a squared plus b squared. So that means that c squared, this hypotenuse, is going to equal 5 squared plus 12 squared. So if you want, on your calculator, you can take 5 squared plus 12 squared and get 169. So that means c squared is 169. The square root, hit second, square root of 169 is 13. So that means c is equal to 13. Well, let's bring the calculator back in here, or the computer rather. We now know that this is 13, so the cosine of angle U is going to be 5 divided by 13. So on some of these problems, you might have to do just a little bit of Pythagorean theorem to get the answer. But the main idea is just to figure out what these different amounts are, okay? So if you want, the Y3 is the IXL for this section. It's not a very difficult section, but again, I just want you to get familiar with the idea of sine, cosine, and tangent, because we're going to be using those quite a bit later on to actually graph those functions. This is still, like I said, kind of review of things you probably have seen already, but that's okay. This is not going to be a real long lesson. Sometimes they're longer, sometimes they're shorter. So anyway, thanks for watching, and I will talk to you tomorrow. Bye.